This is going on page 97 when we're done. And I will tell you when you need your map pencil, okay? Because I want certain things to look different than the rest. All right, so we are going to graph our reciprocal functions, starting with cosecant. So the cosecant function would look like this: f of x equals CSC of x. That would mean cosecant of x, okay? Cosecant is the reciprocal of what? Sine, right? Because there's one co in each pair. So this would be 1 over sine of x. And then we are going to draw a little parent function of sine, okay? Because everything we do with the reciprocals, we're going to look at through sine, cosine, and tangent. So we should be pretty good at sine, cosine, and tangent at this point, which will make our reciprocal stuff even easier, okay? So here's where you need your colored pencil. So grab your colored pencil. And we're going to plot one little cycle of the sine parent function on our graph, which means that I know that I start at 0 right there. I have a point at 0, 0. Let's make a point there. And really, anytime I use my light blue, because I won't forget to tell you to use it, I might forget to tell you to stop using it. But if I'm using this light blue, that's your color pencil. And then the end, so what's the period for sine? 2 pi. So I got one on 0 and one at 2 pi. Then I have another point halfway between the two at pi. Okay, so there are 3 of my important points for sine. Halfway between 0 and pi, I'm up here at 1. So at pi halves, I'm going to plot a point at 1. And then halfway between pi and 2 pi, I'm down here at -1. Okay, so I've got those 5 points. And then I'm going to sketch that in. Like so. And I want it to be a different color because it's technically not part of my graph, but it's going to help me understand my graph, okay? And then we're done with the colored pencil for now. So get your other writing utensil. And we are going to talk about some of the pieces here. So what I have over there is sine. Cosecant is the reciprocal of sine. So right here, when sine is 0, what is the reciprocal of 0? What? Undefined, right? 1 over 0 would be undefined, yes? All right, so that means undefined, I'm going to have a vertical asymptote. So everywhere that sine is 0, cosecant is undefined. Does that make sense? Because they're reciprocals. So I have a vertical asymptote there, there, and there. And then not only that, but just like all the other trig functions that we've done, everything is spaced out evenly and symmetrically. So I can see that I have a vertical asymptote every pi. So I will have one here at -pi and one here at -2 pi. Okay. Everybody good so far? So I've taken those first 3 points, those zeros, they become vertical asymptotes because that's the reciprocal. Then I have a point here where the y value is 1. What is the reciprocal of 1? Don't overthink it. It's an easy question. 1. Okay. And so that is still a point for cosecant. And then I have this point down here at -1. What's the reciprocal of -1? -1. So I have another point there. Let me try to move it over. I need to calibrate my board. All right. And then I think we already kind of see a pattern. We should be able to fill in the other 2 here and here, right? Then I would probably need some more information. It'd give you more information for you to be able to sketch it in. So I'm just going to tell you that when you take the reciprocal, you're kind of, I think of it as taking sine and kind of turning it inside out. So if I'm going to turn it inside out, then where sine is concave down right here, cosecant is going to be concave up. But where I have asymptotes, I have to be approaching infinity or negative infinity. So what that looks like is this right here. They look kind of like parabolas. They are not parabolas though, because parabolas go from negative infinity to infinity, and those have to, approach asymptotes. But it has the same look. Like you can think about it as that. And then this is what your cosecant function looks like. Looks nothing like sine, right? But do you see how we use the sine parent function to help us figure out where the pieces are? Because all your important pieces are going to be, where are your asymptotes? That's where sine is 0. And then where are your maximums and minimums for the little sections? And that's going to be where the maximums and minimums are on sine. Okay? What questions do you have? We good so far? All right, let's look at secant. So my parent function for secant, f of x equals SEC of x, secant of x. And secant is the reciprocal of what? Cosine. So this is 1 over cosine x. So for this, we're going to draw the parent function for cosine, which looks something like that. The cosine never looks as accurate as my sine, but it's good enough for, for what we're trying to get out of it. It's fine. All right, so grab your colored pencil again. And we know for cosine, for the parent function, we start up at 1 on the y-axis, so I have a point there. The period for cosine is also 2 pi, so at 2 pi, I'll be at 1. Halfway between those two, I'm down at -1. So at pi, I'll be at -1. And then halfway between each of those, I'm at 0. So I'll have a 0 at pi halves and at 3 pi halves. And then I'm just going to sketch that in so it's on there. Good enough. Okay. Everybody with me so far? And then you're done with your colored pencil for right now. And just like with cosecant, secant has a vertical asymptote everywhere that cosine is 0. So I know that I'm going to have a vertical asymptote here and here. Right? So your vertical asymptotes are still spaced out pi units away from each other, which means if this one's at pi halves, I'd have one over here at -pi halves, and I'll have one at -3 pi halves. Okay. And then everywhere that cosine is 1, secant is also 1. And everywhere it's -1, it's also -1. Okay? Because those reciprocals are super easy. We could make a more accurate graph by plotting some other points decimal-wise, but it's totally not necessary. We're just trying to get the idea of what's happening here. And then we should be able to fill in the other two over here, right? And then we just take cosine, turn it inside out, just like we did sine. And just like sine and cosine look the same, just shift it over. Secant and cosecant are going to have very much the same look, just shift it over. There is your secant function. Okay. Any questions at this point? Do you see how they're related to each other? And how you can just use what you know about sine and cosine to help you get things about secant and cosecant. Still just focusing on sine and cosine, right? Okay, so then we have cotangent. So parent function would be f of x equals cotangent x. Cotangent is the reciprocal of what? Tangent. So 1 over tangent x. Draw our little parent function for tangent. Looks like this. Okay. Then we are going to, then you can grab your colored pencil. I have this point, tangent starts at 0, 0, so I'm going to put a little point for 0, 0 there. What is the period for tangent? Pi. So this other point is here at pi. Okay. Halfway between those two, I have a vertical asymptote, all with my colored pencil here, just so it's all the same color for tangent. Halfway between the 0 and the asymptote, I'm up at 1. And halfway between the other 0 and the asymptote, I'm down at -1. So I've basically just put that on my grid. And then this is the part that we're dealing with. Okay. And then we're done with your colored pencils. Okay. So just like for sine and cosine, when tangent is 0, when I take the reciprocal, that means that cotangent will have a vertical asymptote. So I'm going to put a vertical asymptote everywhere that tangent is 0. Okay, tangent is 0, it's 0 in pi. But then also, if I keep going, those are pi units away, also at 2 pi. And also at -pi. And at -2 pi. Right? Everybody okay with how I know all that? Just using my reciprocals. Okay, so then when tangent is 1, what is the reciprocal of 1? 1. When tangent is -1, what is the reciprocal of -1? -1. Okay? Excuse me. Now, when tangent is undefined, I didn't mean to make a point there. Excuse me. When tangent is undefined, the reciprocal of undefined is undefined because you can't take the reciprocal of something that's not defined. However, the way we got undefined in the first place is because we divided by 0. We had either 1 or -1 divided by 0. And since we're dividing by 0, that's what makes it undefined. If I take the reciprocal of that, that would give me 0 over either 1 or -1, which turns my asymptote into 0. So I just want to be very specific here in that the reciprocal of 0 is undefined. It's not true that the reciprocal of undefined is 0, but it is true that where you have a vertical asymptote, you will have a 0. Okay, just being like specific math language, like I'm not going to tell you wrong, but that's what's happening. So then there's my little piece from 0 to pi, and then we can repeat that and get the rest of it in there. Go ahead and get those little points in there. And then just like when we got those points for tangent, I can't draw through the asymptotes. So they look like little cubic functions, even though they're not. So they have that look to them with the point of inflection. And then there's your cotangent. And remember, you're not going to have to graph these on your own. I wanted you to graph these because I want you to understand where they're coming from and how they work. But we're going to look at everything through sine, cosine, and tangent, and that will be very helpful. Okay, so while you finish that up, I'm going to give you your first page of your actual notes here. Yeah, just go ahead and grab it. Yeah, just go. It's fine. Okay, this part is going on page 98 when we're done. And these words basically say a lot of what I just said. I'm not going to read those to you, but they're there. And then it reminds you of a lot of what we just talked about, which ones are reciprocals of what. Secant is 1 over cosine, cosecant's 1 over sine. We know that cotangent's 1 over tangent. Remember, tangent is sine over cosine, so cotangent we can also think of as cosine over sine, right? And then the graphs of all of the reciprocals functions will have vertical asymptotes whenever the denominator is 0. That's what we just graphed on our own. But I wanted you to graph those and see what happens without me just showing you. But here's many more cycles of what we just did. They have sine and cosine kind of drawn in the background like we did. You don't have to draw that like on the graph itself every time, but again, you're not going to be graphing them. You're just going to be doing the little parent functions to help yourself. But the graph of secant, what is secant the reciprocal of? Cosine. Okay, so the graph of secant has vertical asymptotes where cosine of x equals 0. Okay, so when is the first time on the unit circle that cosine equals 0? Pi halves, right? And that's what this is right here. We got a vertical asymptote at pi halves. So my vertical asymptotes are x equals pi halves plus, and then they happen every pi units. So it's going to be plus pi times k, where k is an integer. Because there's an infinite amount of asymptotes. They happen every pi units starting at pi halves. And you can go forwards or backwards because k could be positive or negative. All right. We all okay with that? Then we have cosecant. Cosecant is the reciprocal of sine. So cosecant has vertical asymptotes where the sine of x equals 0. When is the first time on the unit circle that sine is equal to 0? At 0, right? And see, we have a vertical asymptote right here at 0. And then they happen every pi units. So since it's at 0, I don't have to even put 0. I just get x equals pi times k, where k is an integer. What questions you got? Anything at this point? That makes sense? Okay, so then it asks about the ranges. All right, so if I think about, we'll just think about this through sine. Since sine and cosine have the same range, secant and cosecant will have the same range. But my range for sine, scroll and I'll scroll back. I'm going from -1 to 1, right? That's my range for sine. But remember, we're turning this inside out. And when we look at the secant and cosecant graphs, where does the range start? What's the smallest y value? Negative infinity. So I'm going to start at negative infinity, use all of the y values till I get to -1. Is -1 a point that's actually on this function? Sorry. It is, right? Because they share this point right there. So -1, I am including it. It is something that I use. And then I skip over all the sine and cosine stuff because I turned it inside out, and I start back over at 1 and go to infinity. Okay. Everybody okay with that? You see how that works? Any questions? All right, then flip this over and let's look at cotangent. So the graph of cotangent has vertical asymptotes everywhere that tangent equals 0. When is the first time on the circle that tangent equals 0? 0, right? Tangent equals 0 here and here. So since it's 0, and I can see that I have a vertical asymptote at 0, right? And then my next one is at pi. So those are pi units apart also. So this will also be x equals pi times k, where k is an integer. Okay. So, and we have to write it out like that because there's an infinite amount of them. It's not like we can list them all, right? That's why we have to have weird things like that. Everybody good so far? Yes? Okay. So let's work some of these and look at how we are going to use sine, cosine, and tangent to help us figure all this out. So we have this equation, and it's not asking us to solve it. It says, which of the following is a vertical asymptote of this graph? Okay, that is a secant function. Secant is the reciprocal of what? Cosine. So I'm going to draw myself a little cosine parent function. And then I know that the vertical asymptotes happen when cosine is 0. So they're going to be right there and right there. Well, I missed, but I need to recalibrate my board. I'm aiming for that. I can't always get where I'm aiming. Y'all see where I'm aiming, right? Pretend like I actually hit the right points right there. All right, but that doesn't necessarily mean that those are my answers. I got to look at my equations. Now, the equation that they give me, that 3, that is a vertical dilation. If I take this graph that I have and I stretch it vertically or compress it, is it going to change where my asymptotes are? No. So this number is irrelevant for this question. Then the 2, that's going to be a horizontal dilation. If I stretch it or compress it horizontally, would that change my asymptotes? Yes, it absolutely could. And that, for trig, really affects the period, right? So I know I'm starting at 0 here because I'm not shifting left or right, but I need to know what the period is that I'm dealing with. So the cosine period is 2 pi, so the secant period is 2 pi. I take 2 pi, divide it by b, which is 2. That leaves me with pi. So I know I start here at 0, I end at pi. Okay. Halfway between those two, this is pi halves. And then I have an asymptote halfway between 0 and pi halves. What's halfway between 0 and pi halves? Pi fourths. And that's where an asymptote is, and my answer is C. Now, let's pretend like pi fourths wasn't an answer choice. Where is this asymptote? What's halfway between pi halves and pi? Okay, I kind of expected crickets, and that's okay. Because here's what I want you to think. When it's lined out on like horizontally, like the x-axis, I think sometimes you think that you don't know these things that I know that you do. If you think about it on the unit circle, okay, pretend like that's actually even. If I go from 0 to pi halves, halfway between those two, that's totally pi fourths, right? Halfway between pi halves and pi, what's your second quadrant pi fourths angle? 3 pi fourths. And see how if you think about it circularly, you can actually come up with those numbers that are horizontal? Because all we did was unroll it. So think about the circle, and then I bet you know those numbers, okay? So 3 pi fourths would also be a perfectly fine answer, because they may not always be the first one that you would come up with, okay? We good? So you have 2 different ways to think about these things, like the new sine and cosine graphs that we've been looking at, or the unit circle, and whichever piece, on one thing, one might make more sense than the other, but don't forget about the circle. Questions about that one? Okay, let's look at example 2. So first thing here is when these equations are written this way, I think that for some of you, and some of you have kind of gotten past that now and it makes more sense to you, but some of you still, it's like we have no idea what to do. What does that 4 do to my function? Because when it's in front, it's like a whole new world for you. I could rewrite this as g of x equals -2 cosecant of pi times x plus 4. What does that 4 do? It's a vertical shift, right? It's also a vertical shift when it's written like that. We're used to seeing it like this. I would prefer to see it like this. But a lot of times when a is negative, they put it at the front. But don't think it's something totally new and different. If you want to rewrite it like that so it makes sense to you, knock yourself out, okay? Just know that it's not something that you've never seen before, and don't do weird things with the 4. Okay, so this is cosecant. Cosecant is the reciprocal of what? Sine. So I'm going to draw myself a little sine function. And then this question is also asking me about vertical asymptotes. I know that I have vertical asymptotes everywhere that sine is 0. Now, that 4 that's going to shift it up and down, does that do anything to my asymptotes? No. The negative, if I reflect it, still doesn't affect it. The 2, not going to do anything, so that's irrelevant also. So once again, I'm just looking at this, which is going to affect the period. Period, I start with 2 pi in the numerator. I divide by b. That gives me 2 in the end. So I start at 0, I end at 2. I have vertical asymptotes at 0 and at 2. Those are not any answer choices. But I also have one here at what? 1. And it's not 1 pi. I divided the pi out. I know we're used to seeing pi's on that, but it doesn't have to be. My answer is just D, so x equals 1. What questions do you have? Anything? All right. Okay, so let's look at 3. This is cosecant. Cosecant is the reciprocal of sine. Okay, and this time it's asking me about the range. All right, well, my range for sine is usually -1 to 1. If I have this 3, that's a vertical dilation. Is that going to affect the range? If I stretch it like this, it's going to affect it, right? It would make this go from -3 to 3 then, right? Does that make sense? We're stretching it. Then this is that theta over 2. That would be a horizontal stretch or compression. Would that affect my range at all? No. So all I'm worried about then is this right here. And since cosecant, I'm really taking sine and turning it inside out. This is actually the range for sine. So I know it's not my answer. The inside out part of that would be C. Okay. What questions do you have? You see how we're still looking through sine, cosine, and tangent? We just have to understand that secant, cosecant, and cotangent exist, and then how to think of them as a reciprocal. All right, so let's look at this cotangent. Cotangent we know is the reciprocal of tangent, so let's just go ahead and draw this guy in. Something like that. There's my little parent function. And I'm looking for vertical asymptotes again. All right, well, that's my parent function. Even though I drew one here, that's not the one I would use because this is tangent. I would actually have vertical asymptotes here, here, and here, because that's where tangent is 0. So here's my real asymptotes, here and here. So that if I have a negative, if I reflect it in the x-axis, not going to change my asymptotes. Vertically stretch it, not going to change my asymptotes. But this will, right? If I take my period, what is the period for tangent? Pi. Pi divided by b, which is 2 pi, and that leaves me with 1/2. Okay? That means I start here at 0, I end at 1/2. So I have vertical asymptotes at 0 and at 1/2. Are any of those answer choices there? Yep, right there for B. I really don't think that your reciprocal function trig stuff, I don't foresee those questions being like crazy difficult because it does kind of come at the end. We just kind of hit on it a little bit. Just understanding as much as what you understand right now is probably going to be good enough for what you need. Okay. All right. So there's one more page to this. While I'm passing out this other one, There's going to be one question on here that we need to use your Desmos for, so go ahead and get your computer out and just get it turned on, because some of your computers take a little bit longer to decide to play nice than others. So just in the morning through fourth period. Yeah. Okay. So while your computers are getting with us, the first two questions don't require the computer, so we'll just move on while they're waking up. Okay. So a few days last week, we were solving equations. We're going to continue solving equations, this time with our reciprocal functions. Does not make it any more difficult, okay? So here we go. We have f of x and g of x. In the xy plane, what are the x coordinates of the points of intersection? So what do I do with these to set something up? Set them equal to each other. So 4 cosecant of x plus 3 equals 11. Now on Friday, we had to focus heavily on this first, but that was because the argument wasn't just plain old x or plain old theta. If it's plain old x or plain old theta, it says I'm going from 0 to 2 pi. I'm going from 0 to 2 pi. Okay, so I don't have to do anything with that right now. The fact that it's cosecant is completely irrelevant right now because I can do a few things before I have to worry about that. So I'm going to subtract 3 from both sides, get 4 cosecant of x equals 8. Then what would I do? Divide by 4. Cosecant of x equals 2. Okay. Now, do you know your cosecant values like you know your sine, cosine, and tangent values? No, you don't. It's not something I've made you focus on, because if we know sine, cosine, and tangent, we got these down as well. As a matter of fact, it doesn't even matter if we know them at this point. But what we need to know is that cosecant is the reciprocal of what? Sine. So I'm going to take the entire equation at this step and not before this step, at this step, and take the reciprocal. So if cosecant of x equals 2, then the sine of x equals 1/2. And then that is something that doesn't freak us out as much, I hope, at this point. I'm going from 0 to 2 pi. Sine is positive in the first and second quadrants. What angle gives me a sine value of 1/2? Pi 6. And then what is my second quadrant pi 6th angle? 5 pi 6. And I've completed that question without having to know any cosecant values at all. But cosecant of pi 6 is 2, because the sine of pi 6 is 1/2, and they are just reciprocals. Okay, you see how that works? So you just solve it to isolate it like you've done before, and then at that step, you take the reciprocal of both sides, solve it like you've been solving it. Okay, what questions you got? All right, let's do example 6. Same thing, we're finding the points of intersection, so we're going to set them equal to each other. So 3 minus 1/2 times the secant of x equals 4. So I start to solve it first. Subtract 3 from both sides. You get negative 1/2 times the secant of x equals 1. Then I would multiply both sides by what? Negative 2. So secant of x equals, so 1 times a negative 2 is a negative 2. We've got secant of x equals a number. This is when it is legal to take the reciprocal of both sides. What's the reciprocal of secant? Cosine. So I'm going to get cosine of x equals negative 1/2. Then cosine is negative in the second and third quadrants. What angle gives me a cosine value of 1/2? Pi thirds, right? But I need my second quadrant pi thirds angle, which is 2 pi thirds. And then my third quadrant is 4 pi thirds. There you go. Okay. What questions do you have? So it's really not any more difficult than the other ones. You just have to know what your reciprocals are. Okay, we good with that? All right, so you should all have your computers up. Just go to Desmos. Before we start typing stuff in, we're going to write something down here and read this question. It says, let P of X equal this. What are the X coordinates of the points where P of X is equal to 2? So basically, I'm setting this equal to 2. So 3 minus 1.7 times the cotangent of 0.5x minus 1 equals 2. Okay, because I got to set up, I got to show something, some sort of setup. But that's not even really how we're going to work it on the calculator either. So when we go to Desmos over here, we are going to type in P of X, literally exactly like it looks, which means I'm doing P, you can use your keyboard for all of this. P of X, you don't have to go to this fancy keyboard, equals, and then we have 3 minus 1.7. I don't have to go to any special menu to find cotangent. I can just use the keyboard and type in COT, and it will know what I'm talking about. Cotangent of, then 0.5x minus 1. Okay. So I have it exactly like it's on there, P of X and everything. Then I also need P of X to equal 2. So I'm also going to type in P of X equals 2. So the red is my P of X function. The blue is right where it hits 2. I can see 3 solutions. There's actually an infinite amount of solutions, but I only want it to go from 0 to 2 pi. Plus, if you look at your x-axis, it's not in terms of pi like we've been looking at when we do that. And so there's some things we need to fix on here. So when I go to the little wrench up here, the little wrench, if they give me a domain, which they did, from 0 to 2 pi, on my x-axis, I'm going to make that go from 0 to 2 pi. And I don't have to go find pi in a special menu. You can type pi, and it changes it to pi for you. Okay, anytime you need pi on there, you just put pi, and there you go. Then here's the other thing. If you look at your x-axis, which I can still kind of see some of it, it's still not in terms of pi like we've had, like pi, pi fourths, pi halves. So even if you do a trig function and you don't change the domain, because maybe you don't need to, if on the step you put pi, then you'll have pi's down there like you want to see, okay? And then you can just click the wrench again to get off of it. So now all I'm looking at is my function from 0 to 2 pi. I can actually even see the pi's in case something was exact. And I will have one answer. There's only one answer that goes there, and that is that one right there. And when I click on it, there's my intersection, which I know you probably don't realize because you haven't been using the Inspires, but that's probably the most beautiful thing about this is that you can touch points of intersection and you don't have to push 1,000 buttons. But that is my answer. So my answer is x equals 4.07814. Okay. What questions do you have? Anything? Okay. Well, we're definitely going to do some more Desmos stuff with the trig just so that we can talk about some of those menus and stuff, but I just wanted you to be able to get through one of them.